we're asked to evaluate this integral. To do that, we need to have the antiderivative. So every time you evaluate an antiderivative of a term with x to some power, you know the antiderivative has to have plus 1 for the power. So negative 6/5 plus 1 is x to the negative 1/5. We know that has to happen because when we take a derivative, this should turn back into x to the negative 6/5. And when you take a derivative, you always reduce the power by 1. So negative 1/5 subtracted by 1 makes negative 6/5. So we got the power sorted out. But look, if you were to take a derivative of this term, the negative 1/5 would come down and multiply, and you'd have a negative 1/5 out front. So that's no good. So we got to compensate by multiplying by negative 5. Now this represents the antiderivative. And you could check it, right? Take a derivative. The negative 1/5 comes down, multiplies, makes 1. And then the power gets reduced by 1 to be negative 6/5. And then we evaluate that between 1 and 32. That's negative 5 times 32 to the negative 1/5. And then this is subtracted by negative 5 times 1 to the negative 1/5. Okay, and just watch your signs there. It's always this, you plug this into your antiderivative and then subtract it by this plugged into the antiderivative. So I do need two minus signs there. And so 32 to the negative 1/5, we could rewrite that as negative 5 over 32 to the 5th. In other words, the 5th root. And then here it's plus subtract a negative, so that's plus. And then that's 1, just 1 to the negative 1/5, so that makes 1. So the 5th root of 32 means we need to find a number so that it multiplies by itself 5 times to make 32. So that's 1, 2, 3, 4, 5. That's 2. So we got negative 5 over 2 plus 5. That's the same thing as negative 5 over 2 plus 10 over 2. So that's 5 over 2, or 2 and 1/2.